Actually, I was suffering internet issue, so I stopped previous live stream session. Now just I started. Miss anyone? I'll wait. Is there any problem in audio, video? Just write in chat box. So now, Vita, just I'm going to continue question as usual. In the previous, I can see video, just I explain what is a rule, what is the formula of radius average of by metallic strip d upon alpha 1 minus alpha 2 into t. Based on this student, I'm going to just start this already I have started one numerical based on this. So what is meant? Two thin metallic strips, one of brass and other of iron, are joined together parallel to each other at a distance at a at a distance 2 mm apart. Sir, what happened last video? Student, I can see last streaming session, Sagar, I was suffering with internet issue. Right, technical glitch. So due to this student, just I stopped beta I can see previous session, right? Now student just I started. This is the new one, right? So in last class beta Sagar, just I explained beta entire derivation. Beta just go and once was previous lecture. Just I explained how formula R average came G upon alpha 1 minus alpha 2 into T. There is what beta central line distance alpha 1 and alpha 2 beta coefficient of linear expansion for whatever material they will mention. And T is what? You can see temperature. You can based on this Sagar Bacha, I'm going to start, or I can say already I have started one good problem based on bimetallic strip. So two thin metal strips, one of brass and the other of iron, are joined together parallel to each other at a distance 2 mm apart. 2 apart to form form a bimetallic bimetallic strip bimetallic strip. If if the strips if the strips are of if the strips are of equal length equal length at 0 degrees Celsius, the radius of the arc the radius of the arc formed by the metallic strip by the by the by metallic strip, right? When heated, when heated to 80 degrees Celsius will be. Now, student, there is some information here which you can keep in mind. Alpha for brass beta 19 into 10 to the power minus 6 per degree Celsius. Student alpha For iron, this is 12 into 10 to the power minus 6 per degree Celsius. Now, beta, I'm going to give you beta data, which option, which you have to mark for the right answer. 1.50 meter, student 3.57 meter, 5.57 meter, and last 0.57 meter. Last student 0.57 meter. Answer me, beta, Sagar. Sagar, beta, just answer me this question, my dear. I can see today class only Sagar is available. Remaining no more candidate. Okay. Sir, can you solve? Yes, why not? Sagar beta, it's not tough beta. It's not tough at all beta Sagar. It's literally very easy. What they ask, this question one more time. Two thin metal strips, one of brass and the other of iron, are joined together parallel to each other at a distance 2 mm apart to form a bimetallic strip. If the strips are of equal length at a 0 degree Celsius, the radius of the arc formed by metallic strip when heated to 80 degrees Celsius. It's easy. Yes, it's simple beta. This is a formula beta. You can use directly. You can use my idea directly here. D upon alpha 1 minus alpha 2 into T. D upon alpha 1 minus alpha 2 into T. Simple, bacha. You can directly use my dear. You can directly use my dear. Okay. So now, student, I'm going to solve this question here as per request of, I can say, Sagar. Okay. Sagar, beta, listen me carefully here. Okay. So, student, simply here, I'll use beta Sagar. What's the in solution, student? What is formula? I can say by metallic strip radius average, my dear. So this is R average, which is equals to D upon beta alpha 1 minus alpha 2 into T bacha. D is what mentioned here? Two metallic strip, one of brass and iron are joined to each other. Distance 2 mm beta. Distance beta 2 mm. So beta, you can write my dear. This is 2 into 10 to the power minus 3 beta. Okay. 2 into what dear? 10 to the power minus 3 my dear. Okay. Alpha 1 minus alpha 2 here. So 19 minus 12. 7 you can write Bachaji. So 7 into 10 to the power minus 6. 7 into what? 10 to the power minus 6. What is the temperature, bacha? That is nothing but, yeah, you can say 80 degrees Celsius. This is what, my dear, 80 degrees Celsius. Beta, what you can say, bacha? This is nothing but it's 80 degrees Celsius. Simple, bacha. What you can say? So this is what? 40. This is what? 40. So, beta, you can write here further. This will goes up. So you can say, bacha, Bombay. Okay. Okay. Beta, Sagar, who is beta this new candidate JT2396? Student, can you write your name? Yes, beta. So this is beta, I can write here. This is 2000 upon beta ji. This is what you can say 28 means 280. Cancel here. So you can say what's that 200. Okay, fine. 200 by beta ji 28, right? So beta further we can solve here. Beta ji 200 by 28. 200 by beta what? 28 here. Further, so student, you can write here 200 by 28 beta. This is 100 by 14. So beta I can say 50 by 7. So answer beta Bombay is coming. Okay, someone wrote Bombay here. Yes, yes, yes. Someone wrote Bombay. Very good. Very good, Bacha Party. Very good, yeah. I'm very happy to see each and everyone. Okay, beta, have a look at next question. Beta, have a look next question here. This is question beta already asked by JE advance here. This is student JEE advance beta 1999 supplementary question bacha. 3 marks. Beta ji supplementary question beta. This is we can say 3 marks, right? Okay. Yes, 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 yes. Your number correct, correct. Noted beta. Noted Sagar bacha. Okay, fine, my dear. So I can say, beta, what's the question here? Note down question with me, everyone. Everyone, note down question with me. It's a question here of J advance, 1999 supplementary, 3 marks. By metallic strip, by metallic strip is formed out of two identical strips, out of two identical strips, one of copper, one of copper, and and the other of brass. Okay. Next bachcha ji, the coefficient of the coefficient of linear expansion, coefficient of linear expansion of two metals are alpha for copper, alpha for brass, alpha for copper which and alpha for brass, full stop. On heating, carefully listen here. On heating, the difference, the temperature, the temperature difference of the strip. God bless you for your reaction. Temperature difference of this strip goes up by delta T, and the strip bends, and the strip bends to form to form to form an arc to form an arc of radius of curvature beta radius of curvature r, then r is student then r is बच्चा see then r is now I'm writing options here. Everyone just go through question first here. Literally beta, it's a good question here. It's not tough at all, but it's conceptually very good question, my dear. So now student, this is options one I'm writing. Proportional to proportional to delta t. Beta options B, inversely proportional to delta t. Beta option C, proportionals to proportionals to mod of alpha of brass minus alpha of copper. Alpha of brass minus, my dear, alpha of copper. Okay. Now, student, this is option number last for this question. Inversely proportional to inversely proportional to alpha of brass minus alpha of copper. Answer me, student. I hope entire question visible for everyone. Answer me, student. Student, this is the question asked by JEE Advanced 1999 supplementary 3 marks. They literally student asked I can say this formula. You can say like that. So anytime, anywhere, you can watch the video. Just answer me, beta. Anyone who currently present in live session? Anyone? Okay. Okay. Anyone answer me? J advance 1 999 3 marks supplementary. Okay. Very good. Student, literally, if you are liking session here, just like video student, show reaction student. It's highly required. Your like, your reaction will help you next candidate. Okay. Anyone? Okay. So now, student, I am just going to reply, just declare the result here of this question. Simply beta, not a tough question here. It's literally very easy question. Yes, beta, multiple choice. Where कौन सा अगर बेटा? Now today I'm not getting a sufficient reply beta from your side. I don't know where you gone. You are not replying anything like on time. Okay, okay. I don't know uh, what you are telling. Because okay, okay, okay. Jeet Vinod. Okay. Bombay Delhi Sagar. Okay, fine. Two candidate eligible for tomorrow dog chocolate. But okay, fine. Yes, beta, it's multiple correct. So have a look here. I can see beta statement to question what says. Already beta mentioned over there. So I'm going to just write uh, answer of this question. Okay, live in secret. So what's the beta formula of radius here? Just now I proved it R of, you can say bacha this is alpha 1 minus alpha 2 mod beta. This is T here. So beta will go through this, right? Okay, okay. Okay, fine. So I can say what's the answer with proportional, no, inversely proportional. Correct here. Bombay Daily. Very good, very good, very good. Jeet and Sagar beta, both of you. God bless bacha. B and D beta, correct answer beta. I can say Jeet and Sagar beta, both of you are correct answer. Jeet and Sagar, literally beta, you are liking session of face point here. Just do one beta, just like video bacha. It's highly required, my dear. It's highly required, my dear. Okay, fine. So I can say this is the beta, I can say discussion about beta thermometry. Right. Okay. Now bacha, just do one more question here based on I can say. Okay, okay. Hello, B65. Okay, fine. Beta, literally there are seven candidates, but I can say there are only 7% like the video, like the session beta. Just like everyone here, quickly fast. Okay. Now beta, have a look next question, everyone. Have a look next question here. If a student, if a rod, okay, you did, yes, increased means you did beta. You correct, Sagar beta. If a rod has means beta chocolate applicable for those candidates here who like the video, showing Dixon regularly, maintaining class notes. Then beta those candidates under just staying live session complete. I can say initial to final means initial to till stop the I can say live session. If a rod has a length, okay, okay, okay. JIGB node, very good. If a rod has length, if a rod has a length L naught as student as temperature T naught as temperature T naught, find find length at temperature, find length at temperature. This is beta. I can take initial beta g. This is T naught. Find beta g length at temperature 2 T naught. If alpha mentioned here, alpha naught T upon T naught. It's a little bit a very good question here. I can see JIT and B65 and Sagar Beta. All of you three joined here literally. Today is very good session, bacha. Hmm. But I know I did only advanced question. This is also a good question, beta ji. Okay, fine. Uh, so bacha, have a look at everyone. The solution, beta. We have to find length of rod at temperature 2T naught. Alpha beta mentioned here. So student, for solution, listen me carefully, everyone. It's a good questions, my dear. What is given data beta? You can write alpha is equals to alpha naught T upon T naught. Beta B, remember everyone here. This result. DL upon L is nothing but alpha into dt. Alpha beta, this beta, this value beta you can put. This value of alpha might here fit in this equation. So now student, I'm putting here alpha over here. So this is alpha naught upon beta g T naught. This is what? T into dt. Beta this is also temperature. This is also temperature. Okay, fine. So dl by L beta. Beta just integrate both side, my dear. So beta, what is the length here? Initially mentioned. If a rod has a length L naught beta. If rod has a beta length, what you can say L naught. So this is L naught beta party. Now you can say this is what? L here. Let us suppose this is the final length of rod. Now beta, what's the temperature? You can see this is T naught. Now beta, see this is 2 T naught. Uh, beta, I can see that beta Arun, there is some problem. Sir, beta Arun, what na? There is technical glitch, bacha. So I stopped the, I can say previous session, bacha. This is the new and fresh, bacha. Okay, very good, beta. I'm very happy to see. No, no, literally, Arun, you are doing good job. Since yesterday, beta, you joined the, I can say, live session of physics one. Literally, beta, it's appreciable your interest in physics one, bacha. Very good job you are doing. Now, beta, have a look everyone here. Arun, tell bacha, what is the integration of dx upon x? Anyone from all of you answer me. Anyone from all of you answer me integration of dx upon x. Yesterday I said this, I can say this integration here. ln x, correct here, correct, Sagar Maharaj beta. This is what ln x beta. So simple bacha, what you can write? This is what ln of L beta. Limit you can apply beta z everyone. Sir, this is ln naught to L beta z. Then beta you can say alpha naught by T naught beta. Integration beta, it's a very simple beta. I can say all of you can answer me this question. All of you can answer me beta these questions, right? Easily. Okay. So beta you can say uh, yes beta. So this is what my dear? T square by 2. Limit beta, don't forget to write here. Hello student, BHA. Beta, this is T naught. This is 2 T naught. Beta, just feed this value bacha party. So ln bacha, you can just beta apply the limit. Yesterday I said here ln m minus n bacha party. So you can write my dear. This is ln of okay ln bacha ln of what upper limit minus bacha party lower limit. So ln bacha ln naught is equals to alpha naught t naught student t square by 2 I'm writing t naught into 2 t naught. This one takes snapshot bacha. Okay, but I got it here. Now, bacha, I can see there are five member here, and like I'm looking only four. How possible, bacha, party? At least five like necessary here. So, bacha, this part I'm doing here on next page. Beta, from here onwards, take snapshot. Student, this part, beta, I'll continue next part. Next part, beta. Uh, bacha, see here, beta. What you can write? This is ln of student L upon L naught is equals to alpha naught beta g T naught beta, this is T square by 2 beta g T naught to 2 T naught. Okay, now which I can say ln of beta L upon L naught alpha naught T naught beta, this is you can say upper limit beta 2 I'm taking out with the upper limit minus lower limit. So 4 T naught squared minus beta g T naught squared. So you can say this is what ln beta L upon L naught beta g alpha naught upon 2 T naught beta. This is 3 T naught square beta. You can say so this T naught finished. So we can write my dear ln L upon L naught, which is alpha naught to 3 T naught. Now, bacha, so beta answer they didn't mention in this form. So beta, what you can say? Okay, very good beta. I can say JT Binod, very good here. Literally, you are also doing very good job, bacha. Yes, beta ji. Beta take anti-log both side. Student take anti-log. Beta ji take anti-log both side, my dear. So you can say L upon L naught e to the power 3 by 2 alpha naught T naught. Right? So, bacha L is equals to L naught a to the power 3 by 2 alpha naught T naught. So, beta, this is your result here. Anyone got your same result? Anyone from all of you? Anyone from all of you? Okay, so literally, beta, it's a very good result. Very good question, my dear. Literally, student, it's a very good question here. Okay, now beta, have a look next year. Concept on thermal stress and thermal strain. Student, concept on thermal stress and beta the thermal strain. Yes, beta. Next question, everyone. I can say concept at little. I'll teach better. Then I'll give maximum questions only in the class. Student, concept on beta thermal stress and thermal strain. Okay, good beta. JT Vinod. Very good. No, no, literally, you are doing good job, bacha, today class. I can say today literally you are doing a good job, bacha, buddy. So concept on thermal stress and thermal strain, right? What is this, bacha? How can we understand here? You can take, bacha, let us suppose there are two fixed support. Student, there are two fixed support. You can take any metallic rod. Beta, this is the fixed support. So do yes. No, but I can say no. If I will go to your textbook, so in your textbook, beta, everything which I'm teaching here, everything mentioned, right? But beta, I got in your micro schedule, beta, they didn't mention. Micro schedule, beta, they didn't mention here, right? So this is students, you can say, बच्चा जी rigid clamp. Beta, what rigid clamp? You can take beta, this is L. L is what? Length. L is what is the length only here. Initial temperature, student, you can take. This is what T. Initial temperature beta, you can take. This is what remains T only. Okay. But I know here, this clamp will not allow. This clamp, I can see with a rigid clamp, will not allow to expand the rod. Will not allow to expand the rod. So what is the things beta which you can analyze? Beta, you can see beta, this is initial condition of rod. But this rigid clamp will not allow to expand. So it can beta for this condition. You can just observe this kind of situation of rod. Right. Rigid beta remains same only. Rigid remains same only, my dear. Rigid remains same only, bacha. So for this condition, what you can say? So temperature is what? T plus delta T, or you can say dT. There is what? Little increase in temperature, my dear. So we can also say there is what? Something change in length as well. If the temperature of surrounding increases, the length of wire will increase due to thermal expansion. Beta G, if the temperature of surrounding increases, the length of wire will increase due to thermal expansion. If the temperature of wire will decrease, it will what? Tend to contract. It will what? Tend to contract, but due to clamp at the ends, it will not allow to contract. Due to clamp adjustment, it will not allow to contract. Okay, so if they will not allow to contract, bacha, so if due to fall in temperature, if due to fall in temperature, delta T, it a contraction would be, right? So what's the contraction you can write, bacha? Already I said here, contraction in rod, delta L is equals to L initial. Alpha is a linear coefficient of linear expansion, and this is what delta T. So you can suppose to be the right here. This is what expression of delta L, right? Now, which I'm going to discuss individually. This is what, my dear, thermal stress. This is what, my dear, thermal stress. So you know, bacha, how can we define thermal stress here? You can understand. Have a look example. Beta, let us suppose you are considering, my dear, over here. This is the, there are what? Two rigid support. What, my dear? Two rigid support. Okay, so there is what? Students, rod is mentioned. Student, this is what you can say. This is what basically rigid support. Right, my dear? So, you know, if you are just supplying heat to a rod, then beta what? There is a normal, you can observe. Student, you can observe there is what, student? Normal. There is what, my dear? Normal. Right. So, beta, what is the thermal stress? It is developed due to prevention of expansion. What is when thermal stress? It is developed due to what? Prevention of expansion of a solid when it is heated. When it is heated. It is developed due to prevention of expansion of a solid when it is heated. Right, my dear? So finally, you can write over here formula of stress. So I hope all of you remember. Otherwise, I'm writing force is stress is what? Force per unit area. Force per unit area. Now, bacha, you know what is stress here? So, students, for getting final answer of this question, I wanted to connect here some few points. You can say Young's modulus into alpha into delta t. You can say, sir, why? Now, beta ji, I'll explain here slowly. You can easily understand how it came. Bacha ji, before going to derive this result, I wanted to discuss about the thermal strain first. Student, take snapshot. So that student, I can turn the page. Okay. Now, Bacha ji, next year I can see, my dear, this is what thermal strain. What, my dear? This is thermal strain. Okay, it's nothing, bacha. It's nothing is already approved multiple times. It's a delta L upon L. What's the thermal strain or strain? Change in length upon original length, bacha. So this is what is equals to alpha into delta T. What, my dear? Alpha into delta T. Okay, fine. Now, bacha, I wanted to write your expression of Young's modulus. What was the Young's modulus? So, beta, what is Young's modulus here? I hope all of you remember. Otherwise, I'm writing. This is nothing but stress upon strain, right? So, Young's modulus beta. Just I'll write every result here only. Stress beta, what we can say? F upon A delta L into L. So, Young's modulus beta, I can write. This is F upon A and delta L by L beta already have written here. Delta L by L is equals to alpha delta T. This is what, my dear? Alpha delta T. Simply can write here. What's the thermal force? You can see it here. This is what thermal force is equals to Young's modulus A into alpha into dt. Young's modulus A into alpha into dt. Beta, we wish to find what's a thermal stress. let's say beta, just take assumption. We wish to find beta, this is thermal stress, right? So beta, what is the thermal stress here? Beta, student, what is the
So it's nothing here. You can say, sir, this is force per unit area. Now you can say, bacha, what is the force per unit area, my dear? Young's modulus alpha delta t. That's why I wrote here, bacha. What's the stress formula? Young's modulus alpha into here, beta. What is stress and strain? Oh, Arun, you don't know. Okay, stress beta, if you are applying, beta, you can understand like this here. Sir, semi solution. I didn't get what you wrote last line. Okay, Arun, I'm telling bacha, what is this stress, right? Stress is nothing, bacha. If we have any body, right? So we are applying force continuously everywhere, anywhere on the periphery of that body. So what we can say, stress is what? It's a normal force per unit area. Arun, beta, it's a normal force per unit area, bacha. That is stress. Strain, beta, you can write. What is the strain? Strain, student, that is, you can say, change in length upon original length. Right, bacha? So this is, beta, I can see formula in today class, which I discussed. Maybe you got disconnected. Thermal stress, beta, force per unit area. So, beta, this is thermal force. What is student? This is student. This is my dear thermal force. This is what, my dear? Thermal force. This is thermal force formula, beta. This is thermal stress. Beta ji, this is thermal stress. Oh, Arun, Sagar, your phone got. Yes, 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 Sagar. You correct, beta. Hello? Yes, 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 Sagar, beta. Yes, Sagar, bacha. So now, beta, this is what? Stress force here. Now, beta, do the question everyone here. J2021. Sagar, beta, now active. Sagar, bacha, now active. I have only 9 minutes here for this session, bacha. Sagar, bacha, I'll, beta, just finish this session within 9 minutes here. 9 to 10 minutes, right? Within 5 minutes. So do few questions, bacha, partly. Today session here got disturbed due to network issues. Beta, this is JE beta 2021. Student, this is what is JE 2021. Beta, note down question fast everyone here. A rod, student, a rod is lying freely. A rod is lying freely on a horizontal surface. Okay, good, good, good. Good, Arun beta. Got it. Arun beta, now note beta this question here. Coming, I'll discuss here 1 to 2 question because already asking JE bacha. Right. So beta, this question asked by JE 2021. A rod is lying freely on a horizontal beta surface. Freely on a horizontal beta J. Freely on a horizontal surface. Find thermal stress. Find thermal stress and thermal strain produced in rod produced in rod if it is heated, if it is heated by delta t, if it is beta heated by delta t. Now student, I'm writing options here. Beta first I'm giving you stress, then stress. What we have to find? Rod lying freely on a horizontal surface, find thermal stress. Yes beta, first I'll write stress then strain here. So this is students alpha delta t, it's a stress. Next beta alpha Young's modulus delta t, beta it's strain. Now beta next option Bombay, student alpha alpha delta t upon 1 plus alpha delta t. Now बच्चा Young's modulus alpha delta t upon 1 plus alpha delta t. Next beta options number C, alpha L delta t, alpha Young's modulus delta t. Beta is the last option 0 0. Now answer me from anyone from all of you. Answer me anyone from all of you. Behind this question, what is the major point which you can keep in your mind? Rod is lying freely on a horizontal surface. Rod is lying freely on a okay. I can say Sagar, I got your answer. Okay, okay, Canada. Anyone answer me? And I can say America, Bombay, Canada, Delhi, Evergreen. Anyone answer me? Okay. Anyone answer me at this question? Okay. I got answer from only Sagar. Now Sagar beta, I'm going to explaining here these questions, right? So you should have a look of solution, my dear. Okay, beta, I know what's the point here. Stress maybe. Okay, sir, it's daily. Okay, fine, fine. Now your answer correct, beta. Sagar, your answer daily correct only. Why you deleted your answer? This is the correct answer only here. Yes, yes, daily only, beta. Daily only, beta. Why? Because beta, for getting for if you want to find stress, beta, have a look example here. This is a rod. Rod is what? Nothing. There is no any force, right? How can you get stress here? You can take example more, beta ji. Let us suppose this rod, this end of rod is free. Now, bacha, yes, yes. Now, let us suppose you are pulling this rod in this direction. Again, there is no stress at all. So, stress you can get in the rod. You better what? One end you can say fixed. Now you are pulling from here only. That is stress. That is stress, my dear. Got it now? Okay. Now, beta, move next question here. Move beta the next question. That is the last question, Sagar beta, for today class here. Okay. Very few candidates joined today class. I was also suffering here. I can say previously, like Vacha ji, network issues here. Now, beta, have a next question, my dear. A metallic rod. Beta, again your question from mains only, beta. J main P by Qs. Student, a metallic rod is fixed between two points, or you can say two rigid support, two rigid support find thermal stress, thermal stress and thermal thermal stress and thermal strain produced produced in produced in the rod if it is if it is heated by delta T. Young's modulus of rod, Young's modulus, Young's modulus of rod is by beta options I'm writing, my dear, as usual. First is stress, next is strain, strings alpha, delta T, alpha, Young's modulus, delta T beta, option A. Second beta is alpha delta T upon 1 plus alpha delta T beta. This is Young's modulus alpha delta T upon 1 plus alpha delta T. Next बच्चा alpha L delta T, alpha Young's modulus delta T, my dear. Last option beta, that is 0, 0. Yes बेटा जी 0, 0. आंसर में बेटा जी क्वेश्चन से यार क्विकली सागर बेटा, क्विकली सागर बेटा, सागर बेटा आंसर में क्वेश्चन. Okay, सागर बेटा this is your assignment here. Tomorrow I'll discuss. सागर बच्चा tomorrow I'll discuss this one, right? Now student I'm going to stop your live session beta. I can say for today this is enough बच्चा.